started the recording, and now let me share the screen with you. Okay, so we were discussing scope of variable. What do we mean by scope of a variable? We had discussed last time that a scope, we can view it in two dimensions. One dimension is the lifetime of a variable. When does a variable starts existing? When is it created? And until how long it lives, until how long it exists, or at what time it is destroyed within the program. Okay, so scope, you can look at it from the point of view of lifetime of a variable. And the other dimension that we discussed about scope was that the accessibility of the variable. Okay, from which parts of the program you can access that variable. In your book, he calls it visibility. Sorry. Okay, so visibility means from which part of the program you can access that variable. Okay, so if you have any questions regarding the assignment, please keep them for later. This is the class time where we discuss topics. Okay, so assignments and other things we can discuss it later. For example, in the second session that we'll have today, regarding the concerns that you have, you can ask questions about the assignment in that session. Okay, so I was telling you about the two dimensions in which we can view the scope of a variable, the lifetime and the accessibility or visibility dimension. So if you guys have any questions regarding that right now. Would attendance be compulsory? What are you talking about? The second session today? No, for that attendance is not compulsory. You are only, if you have concerns, you can come and talk to me. And by the way, it's not only for this course. It's in general, if you have concerns or issues in other courses also, since I'm your advisor, you can talk to me about that also. Okay? So, but attendance is not compulsory. Okay, but if you have issues, then you should come to that class. Otherwise, you can't then complain that we had issues and nobody asked us or nobody listened to us. But attendance is not compulsory for that session. So, no questions about the assignment, please. For the assignment, you can ask in the second session, okay, or send me an email if you like. But right now in the class, we will not be discussing the assignment. We are discussing the topic that we were studying last time. So please, if you have any questions about the scope of a variable, please go ahead and ask about that. Okay, any questions about the scope of a variable? About the lifetime, when is a variable created, whether it's a local variable or it's a global variable, and until what point it exists, and from which parts of the variable, which parts of the program we can access a variable. Okay, the accessibility dimension. Any questions? No? Okay. Okay. If there are no questions, then as I had said last time, there are a couple of other things that are related to the scope, but we were not able to discuss it last time. So we'll start and continue from there. So let's say we have this. Let me open this file. Scope of variable. Okay. So I hope you guys can see the terminal, and I'll make it full screen. Okay, so let me just compile and run to see where we were last time. Okay, so we were basically, we had two functions, f1 and main. Okay, and we have a global variable which we can access from any function. So the global variable is being accessed in f1 at line number 10, and we are printing its value, and the same thing is being done to the global variable in main function from line number 17. Okay, so global variable is visible to every function. We can access it from any part of our program. The second type of variable is global variables, local variables. So we have two local variables on line number 9 and line number 16. On line number 9, we have the local variable f1 var, which is local to f1, and on line number 16, we have the local variable main underscore var, which is local to main. Okay. So local variables, in terms of visibility, they are only visible to the function in which they are declared. Okay. They are only accessible inside the scope of the function in which they are declared. Okay, so f1 var, it can only be accessed within f1, and main var, it can only be accessed from within main. Okay, so local variables are only visible in the scope in which they are declared. Okay, and here in function, scope is defined by these curly brackets. Okay, so by the within the scope, the local variable is not accessible before it is declared. Okay, so let's say if f1 is declared here in this scope, and I want to print the value of f1 var here. Okay, so what will happen when I compile and run this program? Error. Okay, very good. So when I run this program, will it be a compile time error or a runtime error? Compile time error. Very good. And can you guess the statement, the error message that the compiler will give us? Not declared. Okay, very good. It's almost, I think you are right. So let us compile and see what happens. F1 was not declared in this scope. Okay. On line number 10, it gives us an error. But if we go inside set number, on line number 10, F1, we are using F1. It is saying F1 was not declared in this scope, but F1 is declared in the scope on line number 12. So what is the problem? The error message says F1 is not declared in the scope, but F1 is declared. Very good. Okay. So F1 is declared, but it's declared after the use. Okay. Variables, we have to declare them before their use. Okay. So they are accessible within the scope of the function after their declaration. Okay. So they are not visible or not accessible before their declaration. Okay. As we had already discussed a lot of times, that to use anything in our program, we have to first introduce it in the program. Okay. And variables are introduced by declaring or defining them. Okay. So yes, F1 is visible. F1 is a local variable. It is visible in this scope of F1 after line number 12, till line number 15, till the closing curly bracket. Okay, so this line, as you guys rightly pointed out, is giving us a compile time error because we were accessing F1 before its declaration. Okay, so a variable is visible or accessible after its declaration until the end of the scope in which it is defined. Okay, and scope is defined by these curly brackets. Similar thing is true for main variable. Okay, so both local variables, they are accessible after their declaration until the end of the scope. Okay? So for a function, a scope is defined by curly brackets. So this is the accessibility or visibility dimension of the scope of global and local variables. What about the lifetime dimension of the scope of local and global variables? I think you guys told me last time correctly that local variables are created, they start existing after their declaration. Okay, so they are created after the declaration. For example, F1 will be created whenever line number 10 will be executed. Okay, and it will exist or it will live until the end of the function. Okay, as soon as the function finishes execution, F1 var will be destroyed. Okay? Similar thing is true for main var. It starts existing whenever line number 17 is called or executed, and after its creation, it exists or it lives until the main function finishes execution. Okay. That would be at line number 24. Okay, and global variables, I think we had discussed that also, that they are created before main starts executing. Okay, they exist before main starts executing, and they continue to exist until the end of the program. Okay, they will exist as long as the program keeps on executing. Okay, and they will be destroyed only after the program finishes its execution. Okay, so this is kind of a recap of what we discussed in last lecture. Are there any questions so far? Yes, it's sad, but same thing could be said about people. Just like it's true for people, same thing is true for variables also. So any other question? By the way, wait till you reach the course of operating system. There are many terminologies that you would like, I mean, you would find terrible. Parents, children being killed, etc., etc. So any question related to scope of the local or global variables? No? Okay, so let me move further. So concerning the scope of local variables, there's one more thing I would like to tell you, which is that we have the main variable, and let's say in this I declare a for loop for I equal to 0, I less than 5, I plus plus. And we do okay, we print the value of counter. So regarding this counter variable, is it a local variable or is it a global variable? Local, very good. So what value will be printed if I compile and run this program for counter? Five, one, any other guess? 5. Okay. So let us prove by experiment to see what happens when we run and compile this program. Oops. Line number 21. Counter has not counter was not declared in this scope. Line number 24. Counter was not declared in this scope. What? Oh, so there one is a typo. Okay, one is a typo. So we'll fix the typo first to remove any confusion. Okay, so this was a typo. Okay? So we'll run it again to see what was the problem. Again, line number 24. Counter was not declared in this scope. Okay, so let's go and see line number 24. Line number 24 is this, and here it is saying counter was not declared in this scope. What do you guys think of this error? Or what do you make of it, the error message? It is local to the scope of the loop only. Very good. Okay, so again, the scope is usually defined by these curly brackets. Okay, so this loop, the curly brackets of the loops, they basically define the scope of this loop. Okay, so counter variable is defined within the scope of the loop. Okay, so it is only accessible within this scope. So after its declaration, line number 20, it comes into being, it starts existing, and after its declaration on line number 20, it is accessible for the length of this scope until the scope ends. Okay, so there's only one line number 21, so it is accessible. We access it, update its value, and on line number 22, the scope of the loop is ending. Okay, so after the loop is finished, the scope of the loop is also finished with it, and the variable counter stops existing or is destroyed after the scope of the loop. So on line number 24, we are outside the scope of the loop. So counter does not exist, or counter is not accessible after the scope of the loop. So line number 24, this gives me an error. Okay, is it clear, the error message that we got? And what does it mean? So scope is only not limited to function. Almost all curly brackets in C++ define a scope. Just like there's a scope for loop, similarly, there's a scope for if-else. Okay, so anything, any variable that you define within if-else scope, it will not be accessible outside that scope. Is it clear? Okay, no answer. As I have said multiple times, I'm choosing the answer of my choice. So what do I have to do to make this counter accessible after the loop? I want to increment it 5 times within the loop, but I want to print its value outside the loop. what should I do to make this counter accessible outside the loop? Declare it outside the loop. Very good. Okay, so we'll move its declaration outside the loop. So here we go. We have moved it outside the loop. So now it is available for the scope of the main function. Okay, so it is available on line number 24 and it continues to be available until line number 6. Okay, so we use it on line number 21 and then we print the value on line number 24. So let's go and print this value. And hooray. Okay, that is something about the scope. That scope is limited by curly brackets in C++. And just out of curiosity, what will be the value of I if I print it here? Very good. Okay, I is also part of the scope of the for loop. Okay, so if I try to print I here like this, it is not declared in the scope. Okay, it used to be allowed, but now it is not allowed in C++ using I like this. So again, for I, if we want to move or access the value of I after the loop, we'll have to declare it outside the scope of the loop. Okay. So again, we'll have to move the declaration of I equal to 0. Okay. So what will be the output of this program if I run it? If I compile and run it? No, it's not in 0 and 0. It's not 0 and 0. Both variables are declared outside the before the for loop, so they are accessible throughout the main, and the value will be printed after the loop. And during the loop, both variables are accessible. They will be accessed and updated. Okay. So, okay. By the way, there is still a small error in this program. What if I say, if I compile it, I'll get an error. What error? Very good. Okay, I is declared twice. Okay, so within the same scope, we can't have the same variable declared twice. So since we are declaring I outside the loop, we will remove its declaration from inside the for loop. Okay, so now let us compile and run it. I5 and counter 5. Okay, is it clear to everybody why the values are both 5? I declare it won't give an error. No, it will give an error. Let us see. There we go. And oh, it does not give an error. Let me check it again. I is equal to 0 and I is equal to 5. Okay, I'll come to it. Okay, let's come to it now. So both times I was printed, but when I was declared only once outside the for loop, it was giving us the I is equal to 5. And let me remove the counter statement so that we can focus only on the I. So we'll remove this counter statement. Okay. So first of all, let us declare I once and print the value of I. I is equal to 5. Okay. And as Usman pointed out, we can declare it twice here, and we can compile and then run it, and it gives us I is equal to 0. Okay. So who can explain me what is happening? Why is I getting or printing the value 0? Yes, Uzair, you want to say something? Who can give an explanation? Global variable greater than importance of local variable. Acha, first of all, there is some terminology that is wrong. Usman Tahir, what is the global variable here? Is there any global variable?
Sir, may I explain it?
Uh, okay, go ahead.
Sir, first of all, you declared I is equal to 0 before the loop and I
Hmm.
is equal to 0. And after
Hmm.
using it in the while loop, you are only incrementing the value of counter. We are not incrementing the value of I. So it will definitely give us the value before the loop because I is not updated yet.
No, no, we are inside the loop. We are incrementing the value of I. You see this I plus plus?
But we are not updating it, sir. Means the new value, we are not assigning the new value to the I.
No, no, it is being assigned because if I print I inside this loop
Then I is
plus,
local to the loop only. The other reason is there
yes,
that I is only local to the loop.
yes. How many I variables are there in this program?
2.
2. Okay. So earlier I said that you can't declare a variable of the same name within the same scope. Okay. Here, if you say there are two I variables, then are they in the same scope or are they in different scopes? No, we should distinguish between instances of the variable I. There are two instances of the variable I in this program. Okay, there are two variable I's in this program. Can you guys tell me whether those two variable I's are they declared in the same scope or are they declared in different scopes? Let's call these okay, if there are two I's, then one of them is declared on line number 20 and the other is declared on line number 21. So let's, for the sake of our discussion, call them I20 and I21. Okay. So this variable on line number 20, let's call it I20, and this variable I on line number 21, let's call it I21 just to differentiate between the two. Otherwise, they both are named I. Okay, so are these two I variables there declared in, okay, you guys said different scope. So in which scope are they declared? I-20 is declared in which scope and I-21 is declared in which scope? I-20 is declared in the scope of main and I-21 is declared in the scope of loop. Very good, Farid. So when we are, okay, so first of all, since it did not give an error, then now you can guess that you can have two different variables of the same name in two different scopes. Okay, so I hope this conclusion is clear to you guys, that you can have two different variables of the same name in two different scopes. Just like I can have a variable I in function f1 and a variable I in function f2. They are both variables of the name I, but they are in two different scopes. Similarly, here we have two different variables. Both have the name I and both are declared in two different scopes. Right? So I-20, as you guys rightly pointed out, is declared in the scope of main. Okay? And I-20 exists from line number 20 till line number 29. Okay? This is the scope of I-20. And similarly, we have I-21, which is declared on line number 21 inside the scope of the for loop. Okay, so the scope of I-21 starts from line 21 and goes until line 23. Okay, so these are two different variables. They are declared in two different scopes. Okay, so the difference from the example of two variables of the same name in two different functions is that here the two scopes are, one scope is enclosed in another scope. Okay, so this scope of the for loop is enclosed within the scope of the main variable, main function. Okay, so the scope of the main is a superset of scope of the for loop, or vice versa. Scope of the for loop is a subset of scope of the main loop. Scope of the for loop is enclosed within the scope of the main loop. So when you have a situation like this, that you have scope enclosed within another scope, and you have the a variable of the same name within both scopes, in the outer scope as well as within inner scope. So inside the inner scope, if we access this variable, inside this inner scope, I access this variable I, then which variable will I be accessing? The variable I-21 or the variable I-20? The variable I-21. Okay, very good. So the general rule is, if you have a variable declared in multiple scopes and these scopes are enclosed one inside each other, okay, and within a scope you access a variable which has which has multiple instances, then you will be accessing the variable that has been defined closest to the use. Okay, so here if we see from this line number 23, if we start going up, we see that I-21 has been declared closest to this loop, this use, okay, line number 23. So we have to go out, and the first declaration of I that we find, this line number 23 will be using that declaration. Okay, the innermost declaration will be used in the that scope. Okay, so that's why on line number 23 we are accessing I-21. Okay, so throughout the loop I-21 is accessed and I-20 is never modified within this loop. Okay, is it clear? And the same thing applies to global variables. If we have a global variable here, okay, and we are printing, let's say here I print I21, and here if I print I on line number 27, which I will be printed. Okay, now 21 is become 22, so on line number 27, which I will be printed. I21, I22, or I15. Again, these are scopes within a scope. So the key idea is what I said before, that we start going up, and the first declaration that we find, we'll be using that I. So here 27, we move up inside the scope of line number 27. The scope of line number 27 is scope of the main. Okay. So we start going up. We ignore the for loop because that scope is not of our concern. That scope is finished by the time we arrive at line 27. So we go up in the line of the scope of the main loop, and we encounter I21 first. Okay. So here we will be printing I21. Okay. So when a scope is enclosed within another scope, this scope of main is enclosed within the global scope. So inside the scope, if we are accessing at a local or global variable that is defined within this scope as well as the scope above it, we'll be accessing or using the variable whose declaration is closest to this use. Okay, and if we start going up, we see that line number 27, this use, the closest declaration is line number 21. Okay, so on line number 27, we will be accessing I21. Okay, so here let me write I21, and now let us verify this by compiling and running this program. And okay, so inside the loop it's I22 that we are accessing, and outside the loop on line number 27, it's I21 that we are accessing. Is it clear? How scopes are nested within each other, and how we can access, within a scope, when we access a variable, which is also defined in the scope above it, which variable will we be accessing? Okay, I hope it's clear to others also. So the same apply, basically it's a nesting of scopes, whether it's global scope, or local enclosing another local scope, the same rule applies to them all. Okay. So there's one other thing that we can access, we can use is that, let's say here on line number 24, how many I variables are accessible or visible on line number 24? On line number 24, how many I variables are accessible, or how many I variables exist when we are on line number 24? Very good. 3. Okay. One within the scope of the for loop, the other that is defined in the main scope, and the third which is defined in the global scope. So let's say inside the for loop, I want to access not the latest declared variable I, but the one above it. Inside the for loop, I want to access this I declared in main on line number 21. So how can I access this variable within the for loop? So I don't know whether you guys use it or not, but it's a very good for a, it's these two columns. It's called scope resolution operator. Scope. Okay. So I'll just somewhat correct you, Fare, that it's not for global. It's for going one scope above. Okay. So within the main, if you apply this operator, above main there is only the global scope. So it will give you the global variable. But inside the for loop, we are two levels deep in the scopes. Okay. So inside the for loop, if you apply this double colon scope resolution operator, it will access the variable which is one scope above the current scope. Okay, so let's try it here. Okay, so on line number 24, I am accessing the I within the loop, and on line number 21, from within the loop, I am trying to access the I which is in the main scope or one scope above the scope of the for loop. So let us see. Oh, it's accessing the global one. Okay, so I think I might have made an error in my explanation. So it is indeed accessing the global one. Okay, so I take my words back, and this scope resolution operator indeed accesses the global variable. I'll have to look it up how to access the variable which is one above the uh, current scope, because currently the variable I22 is overshadowing the variable I21. Okay, so my mistake, I take it back. Moment Far is correct that this scope resolution operator is used to access global variables. Okay, is it clear? I'll have to get back to you how to get to the variable one above the current scope. Is it clear? Okay, so again, no answers. So let us, there's one more thing that I would like you guys to know, which is related to the scope of the variable. There are some variable, these local variables which are declared on the stack, which are declared in the function, which are created on the stack and destroyed when the function is finished. We call them automatic variables or automatic scope or lifetime. Another kind of variable that you can define within the function, we call them static variables. So static variable, when defined within a function, will basically, let me give you an example. In F2, we declared a static variable F2R, and let's say we increment it. Okay. So now inside the loop, what we will do is we will, okay, so I'll remove this counter stuff and we'll only call F2 here. So I'm calling F2 5 times. What will be the value F printed by the F2 when it is called 5 times? On line number 30. '56. Okay, it will 56 print 56 5 times. That's what you are going, what you guys are saying, right? Okay, first of all, I would like to tell you guys that the value is being printed after incrementing the variable. Okay, so 56 is already the wrong answer. Okay, so 56 is already not correct. And secondly, as Mohammad Farah indicated, we will run it to see because it's easier to believe things when you see them. It's printing 57, 58, 59, 60, 61. Okay, so what is going on? Because static variables are different from normal local variables. Okay, how are they different from normal local variables? How are static local variables different from normal local variables? Normal local variables, they are created every time the function is called, they are used within the function, and they are destroyed every time the function is ended or the function finishes. Okay, so the lifetime of a local variable is only limited to the scope of that function. Static variables behave slightly differently. They are created when that function is called the first time they are created. Okay, so when the function and this f2 is called the first time, this local static variable f2 var will be created. Okay? And once a static variable is created, it is not destroyed when the function finishes. It continues to exist until the end of the program. Okay, so as Mohammad Faris said, they remain in storage and or they continue to exist after the function stops executing. Okay, and they'll store their old value and they will exist until the end of the program. Okay, Mahmoud, this is static is not at all like const. Okay, they'll be modifying. We are modifying it inside the function. Every time the function is called, the variable is modified, but it is created the first time this function is called. I'll repeat again, static local variables are different from normal local variables because static variables are created when the function is called the first time, and once they are created, they are not destroyed when the function finishes execution. They continue to live or they continue to exist after the execution of the function, and they continue to exist until the end of the function. Okay, so every time this function is called, this line number, what is line number? Line number 17, it will be executed only the first time function f2 is called. Okay, so the next time function f2 is called, line number 17 will not be executed. Okay, because static local variables are created only the first time this function is called. Every other time after that function f2 is called, line number 17 will be skipped. Okay, but the variable f2 f2 continues to exist after f2 is finished, and the next time f2 is called, line number 17 will be skipped, but line number 18 will still be executed. Okay, 18 and 19 will still be executed. Only the creation is done for the first time only. The rest of the function is executed every time. Okay, so static variable, first time f2 is called, it is created, it is assigned the value 56, and every other time the function f2 is called, this value of f2 its old value will be incremented and printed. Next time again it will be incremented and printed. Next time it will be again incremented and printed. Okay, and f2 will continue to exist until the end of the program. Okay, so that's the difference between the scope of the local variable, normal local variable and static local variable. Now, the second question that arises is that if the static local variable is created once and exists until the end of the program, the same thing is true for global variables. Global variables are also created once and they exist until the end of the program. So what's the difference between a static local variable and a global variable? Scope, explain please. What do you mean by scope? Scope, I told you scope we can view it in two dimensions, the accessibility as well as visibility. Accessibility as well as lifetime. So the lifetime of this static local variable we have already discussed is starts when the first time f2 is called. Okay, so f2 is created the first time f2 is called, it starts existing, its lifetime start, and the lifetime continues until the end of the program. The difference, as Mohammad Farid said, is in accessibility or visibility. Global variables are accessible from any part of the program. Static local variables, although they exist until the end of the program, but their accessibility or their visibility is only limited to their scope. Okay, so f2 although it exists until the end of the program, but we can only access it from within f2, the function f2. We cannot access f2 from outside f2. Okay, if I try to do this in main, for example, or even inside the for loop, before calling f2, I am trying to access f2. Oops. You see, f2 was not declared in the scope. Okay, on line number 30. On line number 30, it says f2 was not declared in this scope. Okay, because the accessibility of f2 is limited only to the function, the scope of the function f2. Okay, when this for loop is executing the second, third, fourth time, the function, the variable exists f2, but it is only accessible from within f2. Okay, again here outside the for loop, between these two iterations of f2, the variable exists, but it is not accessible. Okay, again line number 33, f2 is not accessible, although it is accessible from within f2. It exists, but we can't access it from outside f2. Yes, Uzair, that's correct. All global variables are static in the sense that they exist until the end of the program. And all static variables are not global because global variables are accessible by every part of the program, but static local variables are accessible only from within their scope in which they were defined. Okay, is it clear about the scope of local variables and static local variables? Uzair, you want to say something?
Yes, sir. Sir, if static variables are not accessible within other functions rather than the function in which it is defined, so then what is the difference between a local variable and a static variable? As the same functionality do the local variables
It
because
is not
they work
exactly
in
the
the.
same functionality. What if this was a local variable? What will be the output of this function if this f2r was a local variable? What will be the output of this function?
Sir, I have not tried it.
But let
Sir,
me try it.
remove static
Let let me try
from
it.
it.
I've removed the static and let us. So you see the output here and the output here. You see the difference?
Yes, sir.
Because when it's normal local variable, it is created every time and it is initialized every time. But when it's a static local variable, then it is created only once, the first time function f2 is called.
Okay, sir. Understood. Thank you, sir.
Any other question? Okay, so if you guys don't have any other question, then we will basically meet at 6 o'clock. I'll join here at the same place on MS Teams, and we can discuss your concerns about this course as well as about other courses that you guys are taking. Okay, so take a break, mark your attendance here in chat, take a break, and let's meet here again at 6 o'clock. And I'll take your leave now and see you at 6. I'll stop the recording before leave.